Okay, so this is the very first question that we would be talking about today, and here are the paper details. You can just note these and then we can talk about the question.
Okay.
All right, okay. So this question again is from differentiation. Let's talk about it now. A function f is defined for x greater than 1 by 2 and is such that f dash of x is 3 into 2x minus 1 power 1 by 2 minus 6. Find the set of values of x for which f is decreasing. Okay. So yesterday I told you, whenever you come across the word stationary point, just know that the derivative is equal to 0. Nature of stationary point, think about the second derivative. Function is increasing or decreasing, it's very simple. If you have a graph that's going up like that, this certainly means that the function is increasing. And what does it mean? That dy by dx is greater than 0. However, if I talk about it other way around, so let's say if I have something of this type, now this is going to imply that my function is decreasing and the derivative is basically going to be less than 0. So this is what we need to understand. Whenever your function is decreasing, the only thing that should come to your mind is that your derivative f dash of x is going to be less than 0. And if it was increasing, f dash of x is going to be greater than 0. So this is something that I wanted to talk about. We have already done one question of this type in the past. Anyways, f dash of x is already given, so let's just write that directly. 3 into 2x minus 1 to the power 1 by 2 minus 6 is less than 0. I'm going to simplify this. 2x minus 1 power 2 is less than 6 divided by 3. I've taken 6 on the other side and then I've taken this 3 as well. This is going to give you 2x minus 1 to the power 1 by 2 is less than 2. I need to get rid of this 1 by 2, so I would be squaring both sides. This 2 and 2 would be cancelled. And this is going to give me 2x minus 1 is less than 4. And finally, I am going to get 2x is less than 5 and x is less than 5 by 2. So the question was, find the set of values for which f is decreasing. Okay. Now we know that f is defined for this, for all the values of x greater than 1 by 2, and it is a decreasing function for all the values of x that are less than 5 by 2. So finally, I am going to write the final answer as x is greater than 1 by 2, but it is less than 5 by 2. And this is going to be the answer to this question. Yes. Any difficulties with this?
Miss, wait one second.
Mm-hmm.
Okay, Miss, fine.
Okay, very good. Munja, are you okay with this?
Yes, ma'am.
Okay. Let's talk about the next question. Okay, now this is another question, again, extremely important. And here are the paper details. Okay. So let's talk about this question. It says the equation of a curve is y equals x cubed plus x squared minus 8x plus 7. The curve has no stationary points in the interval this. Find the least possible value of A and the greatest possible value of B. Just think about that, okay? Now, Rafa, you can use whatever you were telling me yesterday. Now, this certainly is a cubic equation. So this would imply that we are going to have a cubic curve, right? So we can just think about it logically now. This basically means that if I talk about the graph of x cubed, it's going to be something of this type, right? Something of this type, a random graph. And they're saying that the curve has no stationary points in the interval, this. So find the least possible value of A and greatest possible value of B. Okay. Now the curve basically has a stationary point at this point. That is basically going to be its maximum point, and then at this point as well, this is basically going to be its minimum point. And then it says the curve has no stationary points in the interval that is from A to B. This means that the curve does not have any stationary points over here at this time too, and at this time too, right? We have three such intervals where we do not have any stationary points, okay? Yes, are you guys understanding the idea behind the question?
Yes, miss.
Okay, okay, very good. Now, we are not sure about which interval exactly it is going to be. So we have been told that we need to find the least possible value of A and the greatest possible value of B. So let's do that. Now, when I am going to find the stationary point, that is going to give me this coordinate for A and this coordinate of B. This means that they are talking about this center interval, right?
Yes, miss.
Okay, very good. So we'll get back to this logic again, but before that, we need to talk about the stationary point. So let's do that. So for stationary points, we do dy by dx equals 0. Now dy by dx is what? Dy by dx is basically, this is 3 would come here, 3x squared plus 2x minus 8, and this is equal to 0. I've differentiated this and I've equated it to 0. And next I need to figure out the values of x in order to simplify this. So this would give me 3x squared plus 2x minus 8 equals 0. Now at this point, you can try factorizing it, or you can do it by the quadratic formula. So please tell me the two values you get for x. This is just a simple quadratic equation.
Minus 4 and plus 6.
Yes, 4 and 6, right? Very good.
Mm.
So this would give you 3x squared plus 6x minus 4x minus 8 equals 0. 3x common, x plus 2 minus 4 common, x plus 2. And finally, it is going to give you x equals negative 2 and x equals 4 by 3. So these are the two values of x. Now, as per the logic, it's a cubic curve. It's going to be something of this type. So this stationary point is going to be -2, and this one is going to be 4/3. Why? Because obviously -2 comes before 4/3. And this means that the greatest possible value of B could be 4/3, and least possible value of A could be -2. So you can give the final answer as A is equal to -2 and B is equal to 4/3. So this is going to be the final answer.
Okay.
Yes, take a minute or so and just have a look at it. And if you have any questions, you feel free to ask me.
No, it's everything's fine.
Okay, perfect.
Brilliant.
Yes.
Without, I mean, looking at your diagram there, is it given that, I mean, A should be or -2, or say, or it's just from the logical point of view from
Yeah,
the question?
it's just from the logical point of view, because we know that this is the interval that is lying between two stationary points. Why? Because
Okay.
it has no stationary point, right?
Okay.
So
Yeah.
that is why. Okay, perfect. So this part is done. We have practiced enough questions. Now at this point, I would like to talk about some second order derivative things, and then we would be going to the next chapter, that is further differentiation. But we have already covered quite a lot of part about further differentiation, so that's good. Okay. Now I would be shifting to the PDF again. Okay. Right. So just consider this as a practice question for you guys. One last thing from this chapter, because I just need to see if we are confident about it or not. It's very, very simple. Given that y is equal to 5 divided by 2x minus 3 cubed, find this. Okay. Now this is your equation for y, and you need to find the second order derivative. You can call it the second order derivative, second derivative, whatever you're comfortable with. Okay. So this is basically the next question, and it is for you guys. So I'll give you 4 minutes, try doing it, and then we will talk about the next concepts.
Yes.
Yes.
I find -30 over 2x minus 4 to the power 4.
1 second only. 1 second.
Yeah, I think I did.
So just try doing that once again. Just try different. Do you need to differentiate it twice? Okay. Sorry.
Okay, yeah, okay. 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 So it becomes minus 240.
I got the answer.
Okay, 1 second, please. Right. So you guys have differentiated. Okay, and what are you getting?
I got minus 240 over 2x minus 4 to the power 5.
Okay, and what about you, Rafe?
240 divided by 2x minus 3 to the power 5.
Yes, this one is correct. Munjia, you made some minor mistake. So you were getting 4, it's actually 3, and it's
Oh, I don't know why I put 4 instead of 3. Sorry.
yeah, and it's positive 240. Why are you getting it negative as negative 240?
Because if I take the denominator to,
Numerator.
my power becomes negative.
Yes, exactly. But when you will differentiate that again, so negative again, it would be a negative number in the power, right?
Okay, yeah.
So this would become 240, okay?
Yeah, okay, yeah, that's true.
Okay, very good. Well done. I'll
It's
just do it
mistakes I
quickly.
made.
You
Yeah.
can just go through it and also for Mutasam.
Mm.
Okay, so this is first of all, I know I need to differentiate it, so I would take my variable to the numerator. So y is equal to 5 into 2x minus 3 power minus 3. And now I am in the position to differentiate it. So this is negative 3. I'll multiply it by 5. Dy by dx is going to be negative 15 into 2x minus 3 power negative 3 negative 1 would make it negative 4. Next, I need to multiply the derivative of whatever I have inside these brackets, and that is 2. So this is going to give me negative 30 2x minus 4, 2x minus 3 power negative 4. Now this is basically the first order derivative, and in the question I was told to find the second order derivative. So now it's basically the second order derivative. And now I would be multiplying this negative 4 with this negative 30. So this would become 240. This would become 120. Overall, it would be 240, but let me just do it stepwise. This would be positive 120 into 2x minus 3. In the power, we have minus 4 minus 1. That would become negative 5. And I would be multiplying this with the derivative of whatever I have inside these brackets. That is 2. And finally, this would become 240 divided by 2x minus 3 to the power 5. This is going to be the final answer. Okay. All right.
Okay.
Very good. Well done. So this part is done. Okay. Now, like we have discussed a few things, a few topics and differentiation. Other than the simple differentiation, we know the link in tangent lines and curves now. The next topic or the next chapter is basically further differentiation but they are more or less the same because we have already discussed some concepts about further differentiation. But I would certainly like to talk about it more formally because now we would be talking about everything that is included in this chapter. Okay, so in the past, we had some discussion about stationary points. This time around, again, we are going to talk about stationary points, but a different type of stationary point. Okay, so this is the curve for a negative cubic equation. This is basically the minimum point, this is the maximum point, but we say that this is the stationary point, and we consider this as the stationary point as well. Okay. Acha. What is the gradient before the stationary point? Is it positive or negative? It's negative, right? Because if I make a line at this point, it would be coming downwards. And if a line is coming downwards, that implies that the gradient is negative. What about the gradient of the slope after this stationary point? Again, if I make a line, very good. It's going upwards. So it's positive, 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 and perfect. So this is the minimum point, and before the minimum point, my gradient is negative, and after the minimum point, my gradient is positive. Okay, perfect. Let's talk about this one. Now, as we have just seen, if I make a tangent line at this point, it's going upwards, so the gradient is positive. And if I make a tangent line at this point, it's going downwards, so the gradient is negative. So what does that imply? This very stationary point was basically a maximum point, and we can see that the gradient before the point was positive and after the point is negative. So this discussion is extremely important. So far, we only know two types of stationary points. Either it is a minimum point or it is a maximum point. How do we determine that? We determine that by calculating the second order derivative. And if that second order derivative is negative, our stationary point is a maximum point. And if it is positive, our stationary point is a minimum point. But what if the second order derivative is zero? I mean, that is also possible. What if we get the second order derivative as zero? That is going to be another case, right? So let's talk about that. So far, and in most of the cases, we have discussed the minimum and maximum points, right? But what if I talk about the equation of y equals x cubed only? This time around, I'm talking about y equals x cubed, okay? So it's y equals x cubed. If I make the graph of y equals x cubed, this is the graph of y equals x cubed. Now I can clearly see that even at this point, if I calculate the derivative, since if I make a tangent line, it is going to be a horizontal line. Again, at this point, the derivative is going to be zero. So whenever the derivative is zero, what does that imply? dy by dx is going to be 0, and that implies it's going to be a stationary point. But what type of stationary point is it? Is it a minimum point? Is it a maximum point? Well, by the looks of it, it's neither the minimum point nor the maximum point. And if we look at it conceptually, so we know that in case of minimum points, we have a negative gradient before the stationary point and a positive gradient after the stationary point. And for maximum, it's other way around. What about the gradient before and after in case of this stationary point? So if I make a tangent line, very good, excellent. It's positive, positive, before the point and after the point, if I make the tangent line again the gradient is positive. This means that my gradient is not changing before and after the point, but still the point is a stationary point. So this is basically called stationary point of inflection. This basically means that yes, you would have a point on your curve where the derivative is going to be 0, and that very point is your stationary point, but it is not the usual stationary point. It is going to have something different, and that different thing is that it would neither be the minimum point nor the maximum point. It would be the point of inflection. Why? Because it's lying in between, and the gradient is not changing its nature before and after the stationary point. Okay, now what is your hint and how do we think about it?
It's like when the gradient before and after that stationary point is going to be same, like it's not going to change. Then we are
Yes,
going to start this stationary point of inflection.
exactly. Excellent. Very good. Okay, so it's dy by dx equals 0. This is your first thing to identify stationary point, and this is how we do in every case. But how do we know if it's the point of inflection or not? So for that, you need to think about it this way. The gradient changes from positive to 0, okay, and then to positive again. Now, what does this mean? This basically means that the gradient was positive here, and then at this point it became 0, and again it is positive. Similarly, it could be for negative as well, from negative to 0 and then to negative again. So the curve could be other way around as well, right? In that case, again, this is going to be your point of inflection. Yes, Munja and Rafe, any questions?
No, miss.
Yes, Munja?
No, miss, I'm okay.
Just take a minute and go through the concept again because it's very, very important, and then we'll talk about it.
Miss done.
Okay, perfect. Very good. So this is done and we are clear about it. Okay. So this was the very first thing in the next chapter, that is further differentiation. And we already know whenever a curve is increasing or decreasing. Let's talk about one question. Okay. Find the coordinates of stationary points on the curve y equals x cubed minus 12x plus 5 and determine the nature of these points. And the last part says sketch the graph of y equals x cubed minus 12x plus 5. Okay, now this time around it's a cubic curve, and Rafi, now you can certainly use that thing that you were telling me yesterday, because now it is going to be a cubic curve, and just by looking at the values of stationary points you can try making sense, right? But you know, the example we were talking about in the last class was not about a parabola, right? That was not quadratic. It had an x in it had one x in the denominator as well. Anyways, let's talk about this now. Okay, the very first part says you need to find the coordinates of the stationary point, so that implies I need to find the derivative 3x squared minus 12, and I need to equate the derivative to 0, and this is going to give me x squared equals 4, and this is going to give you x equals 2 and x equals negative 2. Now this 2 and negative 2 are what? These are basically the x coordinates for the minimum points, and here you have been asked to find the coordinates of stationary points. So a point means both the x and y coordinates, right? So first of all, let's just do some working and find the y coordinate at this point. So for x equals 2, y is equal to 2 cubed minus 12 into 2 plus 5. This would give you 8 minus 24 plus 5, and that is basically going to be 21. And for x equals negative 2, y is going to be negative 11. So the two stationary points are negative 2 and 21. This is y. And the other one is 2 and minus 11. Okay, I've just made small mistakes here while writing it down. It's going to be for negative 2, negative 2, negative 8, and this would be positive, and yeah, that's fine. Okay, so these are the two stationary points. Now I would want you guys to determine the nature whatever way you're comfortable, and just tell me if this point is a minimum point or a maximum point, and if this point is a minimum point or a maximum point.
Miss minus 2, 1 is the maximum, and the other is minimum.
Minus 2, 21 is the maximum, and 2 minus 11 is the minimum point. Very good. That is right. This is basically your maximum point, and this one is your minimum point. Okay, Munja, are you getting the same? Yes, Munja, can you hear me?
Yes, yes, ma'am.
Are you getting the same
Yes,
points? Like the nature is same for you as well? Okay, very good. Now, you have been asked to plot this. So in order to sketch the graph, it's very simple. When you know which point is minimum, which point is maximum. This is my y-axis. This is the x-axis. Now I know that the maximum point is in the negative part. So it is going to be something of this type. This point is basically going to be negative 2 and 21. And this point is going to be 2 and minus 11. So this is basically the graph or the sketch of this equation. Yes, are we clear with this as well?
Yes, miss.
What about you, Munda?
Yes, ma'am.
Okay, very good. Acha. The next thing is just going to be a discussion about the concept. Okay, now the very first day when we started differentiation, every time I was writing dy by dx, and there I told you that this dx is very important, right? It is dx most of the times, but it could be du as well. It could be dv as well. It could be dt as well. Okay. So if we talk about, this is the next unit basically. If we talk about some, sorry, some practical maximum and minimum problems. Okay, so this is going to be something that is related to the application part of this chapter, like where exactly this thing is applied. Let's talk about one question and then this idea would get clear. Okay, now you basically have a cuboid. The question says the surface area of the solid cuboid is 100 centimeter square and the volume is V centimeter cube. Part A says express H in terms of X. I'll talk about H as well. Part B says show that V is equal to 25x minus 1 by 2 x cubed. Okay. Let me make the cube here, like I'll try making one. Second. Okay. This side is x. This one is also x, and this is h. Okay. Acha. Now the question says the surface area of the solid cuboid is 100 centimeters square. We are coming from O levels. We know what exactly the surface area is. Surface area is the area for the sides of this cuboid, and the volume is V. Express H in terms of X. So we know that the surface area is going to be, if that is H, this part would also be H, and in total we are going to have x squared for the bottom, x squared for the top, and then we would have xh for one side, xh for the other one, xh for the third one, and xh for the fourth one as well. And this is going to give you 2x squared plus 4xh. Okay, I've just used these variables to simplify, and this is the surface area, and the surface area is given as 100 centimeter square. The question is to express h in terms of x. So at this point, I am going to take this 2x squared on the other side. 100 minus 2x squared is equal to 4xh, and it is going to be 100 minus 2x squared divided by 4x equals h. And we are done with the first part of this question. Okay. The next part says, show that the volume is basically equal to 25 x minus 1 by 2x cubed. Again, this is easy. We know that. Why is it easy? It's easy because if I talk about the volume is going to be length multiplied by breadth multiplied by height, and that is x squared into h. And when you will plug in this value of h here in this h, you would be able to show this. Please take a minute and just prove that v is equal to 25x minus 1 by 2x cubed. Do that quickly. The third part is relevant to our discussion.
Done is.
Very well done. And what about you, Munja? Are you done as well?
Yes, ma'am.
Okay. Let's talk about the last part. That's the most important one. The last part says, given that x can vary, find the stationary value of v and determine whether this is minimum or maximum. So this is the concept. The concept is that you have a cuboid and two of its sides are basically equal to x and the height is h. Now x can vary. This, you know what this means? This basically means that consider x as a variable with which you can differentiate, because we know whenever we differentiate, for example, if I talk about y equals 100 kx, y equals 100 kx, I am differentiating it with respect to x. I would consider 100 and k as well as a constant, and I would write this as my derivative. I would only consider x as the variable. So that is why they have mentioned this, that you need to differentiate with respect to x. X is going to vary. So x is basically going to be used as the variable. Okay. And again, you have been asked to find the stationary value of v. So we have the equation of v as v is equal to 25x minus 1 by 2x cubed. This is v. And now you need to differentiate it. So dv by dx is basically going to be 25 minus 3 by 2 x squared. And in order to find the stationary values, we need to equate this to 0. And this is going to give you x equals 5 root 6 by 3. You can just make x the subject here. And it is going to give you 5 root 6 by 3. Now we are done with this part. This is just the value of x. You need to find the stationary value of the volume. So what do? We are going to plug in this x value in the volume. Minus 1 by 2 and then x cubed. And the volume is going to be 68 centimeter cubed. Next part says determine if this is a minimum or a maximum point. So how do we determine that? By differentiating it again. By differentiating this part again. By finding the second order derivative and then by plugging in the x coordinate. Okay. So if I find the second order derivative, it's v basically, it's not y. It's d2v by dx2. And that is going to give me negative 6 by 2x. That's negative 3 by x. Okay, it's negative 3x. And I know that this x value is positive. So when I will plug in this value, it is going to give me positive. It is going to give me the overall answer is going to be negative because this x is positive and negative multiplied by positive is negative. So when the second derivative is negative, it's going to be the maximum point, right?
Yes, miss.
This is the idea. Now for this part, we did not talk about the typical dy by dx stuff. No, we have basically used this knowledge practically. That we had some cuboid that has x and x as its two dimensions, h is its height. First two parts were easy. For the third part, you were supposed to find the stationary value of v. Stationary value means derivative is 0. Derivative, not dy by dx. V is the variable, x is the variable, so dv by dx, right? And upon differentiation, we got this. We have equated that to 0. And the x value of the stationary point was this, and the v value was 68. Next part was to determine if it's minimum or maximum. We have computed the second order derivative. We got negative 3x, x was positive. So overall the answer would be negative. And negative second order derivative implies that it is going to be a maximum